Okay, and we live again. I am sick again too, so I'm gonna do my best to not sneeze, cough, snort, sniffle, or whatever in this video. This is just a recap from what we did on Monday for lesson 16. In lesson 16, we went over perfect squares and perfect cubes. I'm just gonna do a quick rundown on this. I'm gonna try not to take all day and waste time. Out the gate, write this formula. When you see perfect squares, think x squared. When you see perfect cubes, think x cubed or x to the third power. That is the formula for those particular vocabulary words. If you need to understand the breakdown of the both of them, you can compare x squared to area, because the formula for area is length times width. If we were dealing with an actual square, for cubes, if you need to relate it to a formula, you can think about volume. Okay? And the formula for volume is length times width times height. And I'm going to do my best to make a cube here. Okay, it didn't come out bad. So, if I was trying to find the volume, it would be length times width times height over here. Like that. So, just beware. Perfect squares, x squared. Perfect cube, x cubed. This was our warm-up. If you didn't complete the warm-up, just stop and pause here. I would beware of the negative and the positive signs. If you did complete the warm-up already, then just keep moving forward. I did do number 1 for you. Number 1 gives -4 times -4. A negative times a negative is a positive. A negative times a positive, whether if it's the negative first or the positive first, will give you a negative, and then a positive times a positive obviously will always be a positive. In this case, we have 2 negatives multiplied. That'll give us positive 16. If you need to, take time to complete 2 through 6. If you're done, then we're moving on. In this lesson, we're going to figure the best way to determine the difference between squares and cubes. This was our first activity here. It says use what you know about the area of a square to complete the table. I already gave you the formula x squared. So all that means is to plug in these given values here into this x squared formula. So that'll give you 1 squared, which means 1 times 1. Okay, 1 times 1 equals 1. That's it. Same thing here for number 2. 2 squared. 2 times 2 is 4. For 3, we're going to plug in 3 squared. 3 times 3 is 9. 4. 4 squared, that's 4 times 4 is 16. That's it. Nothing more, nothing less. Make sure, remember, that when you are squaring something, you are multiplying the number to itself. You are not multiplying the number times 2, the squared power. You're multiplying the number to itself. That 2 up here, this is just your order of magnitude. Your exponent is just telling you how many times or how many numbers you need to multiply. So notice every time we have a 1 and a 1, that is 2 1s. For 2 squared, that's 2 2s multiplied. For 3 squares, that is 2 3s multiplied. For 4 squared, that's 2 4s multiplied. That's all that means. For number 2, it says, suppose a square has an area of 25 square units. What is the side length, and explain how you know. I did introduce the component of square rooting, which is essentially the idea of working backwards from a squared power. So if I ever need to go from 16, let's say, and I need to figure out what was the original number we were working with, then you, in that case, would square root 16, and you would figure, okay, what number multiplied to itself will give me 16, and that'll give me 4. Okay? Now for number 2, it gives us 25. I know off the top of my head that if I square rooted 25 to get the original x value, because that's what the side length is that it's looking for. It's looking for the original x value. Off the top of my head, I know that 5 times 5 is 25. So my x will equal 5. Okay, because I would have to square 5. But I would likely give you the chance to work with a calculator anyways. So we're just going to plug it in here. That is my square root symbol there. I already plugged it in. Then we put in 25, press equal. That gives you 5. Same thing. That's how you do it on the calculator, okay? Get that out of my way. And we're done with it. Explain how you know, because when you reverse the... Ooh, hold on. There we go. When you explain how you know, you would state that when you reverse the function, or when you perform square rooting, you would get 5. Because 5 squared, or 5 times 5 is 25. That's it. You don't need to say anything special. That's what these two are explaining, so we're going to ignore these. For number 3, same thing, except for this time it gives you what do you know about, use what you know about volume of a cube to complete the table. I gave you the formula of x cubed. That cube is how many times you're going to multiply the number to itself. For number 1, we will write 1 cubed, and I'm going to do it at the top just so I can have some space. That means 1 times 1 times 1, which equals 1. If I did 2 cubed, that gives 2 times 2 times 2, which equals 8. Same here for 3. 3 times 3 times 3 is 27. Same here for 4 cubed. 4 times 4 times 4 will be 64. That's it. Number 4 says, suppose a cube has a volume of 125 cubic units. What is the edge length, meaning what is the x value? So x equals what? And explain how you know. Now, off the top of my head, I know that the answer is 5 is just because I'm just that good and I've been doing it just as long. But for the sake of displaying it to you, we're going to plug in our cube root symbol, like how we had the square root symbol. We're going to use our cube root symbol. That's what it looks like. That's how you work backwards from cubed values. Our number was 125. We're going to plug that in, hit enter or equal, and that gives us 5. That's it. That is it. So our x equals 5 units. Come on, Lumen. There we go. So our x is 5 units. Explain how you know, because 5 cubed is 125. If you perform the cube value, then you will get 5 units. That's it. On this slide, this is just a written out version of the concept of what we're doing, that when we multiply 2 equal factors, meaning when you're multiplying the same number to itself, and we're only multiplying it 2 times, we say that we're squaring the number. When we multiply those same values to themselves 3 times, we say that we're cubing them. Okay, a total of 3 times, or using 3 of the same number, better yet. Here is a quick definition for you of a perfect square. If you did not write this down, pause here and write this. A perfect square is a square of an integer, like 4 is a perfect square because if I was to square root it, that'll give me 2, because 2 times 2 is 4, and we get a whole number if we perform the opposite operation. Now 6, that is a typo. That's supposed to say 9. 6 is not a perfect square, but 9 is, because when I square root 9, I'm going to get 3. Why? Because 3 times 3 is 9. Same thing here for 16. 16 is a perfect square because if I was to square root 16, that'll give me 4. Why? Because 4 squared is 16. There's a reminder of what an integer is. Integers are all positive and negative numbers and 0. Just something to be aware of. Okay? On this slide, same thing. If you did not write down the definition of perfect cube, Write this down. A perfect cube is the cube of an integer, like 8. Because 2 times 2 times 2, like how we did in the example for number 3, is 8. So the cube root of 8 will be 2. And we get a solid number again, not a decimal, not a fraction, not a piece apart or a partial number. We get a solid whole number if we were to cube root these values. Same thing with 27. If I was to cube root 27, we get 3. And once again, if I cube root 125, like how we did for the example in number 2, that'll give us 5. Those are perfect cube values. Here we completed this Venn diagram. We just labeled one side perfect cubes, This was perfect squares. In the middle was both. If you labeled it the opposite way, that's fine. It doesn't matter. Just make sure you can distinguish between the both of them. One side needs to be cubes and one side needs to be squares. The middle needs to stay both. For number 5, we categorized these lists of numbers to determine whether if they would go in perfect cubes, perfect squares, both, or if it was neither and we should leave them off the list. Off the top, we're going to cross out 81 over 100 and 0.027. The reason being is because even though we can square root and we can cube root both of those numbers, but they do not qualify as perfect squares or perfect cubes because they are partial numbers and they are not whole numbers. And when we're dealing with perfect values, they have to result in a whole integer, not a partial one. And I'm going to just do a few of these numbers here. For 50, I know off the top of my head that if I was to try to square root or cube root 50, I wouldn't get a whole number. And if you need to double check that, we're just going to perform it here. There's our square root. We plug in 50. That gives us 7.071. That is not a solid number, though, meaning it is not a whole number. That is a decimal number. So that's why 50 would not fit in either category. Off the top of my head, I know if I square root 121, I'm going to get 11. So that is a perfect square. For 64, I know that 4 times 4 times 4 is 64. But I also know that 8 times 8 is 64. And both of those numbers will qualify as being perfect squares and perfect cubes. It's just more than one value that can give us the same number. So 64 would be both. 0, same thing, would be both. Because 0 times 0 is 0. If I multiply it by 0 one more time, it would be still 0. So that is both. Same thing with the number 1. 1 times 1 is still 1. If I multiply that to 1 one more time, that is still 1. When we come to negative 64, if I square root negative 64, I won't get a real value. The reason being is because a negative times a negative is still a positive. So if I did negative 4 times negative 4, and we do have to multiply the exact same numbers, it cannot be a mix of signs. Negative 4 squared will give me positive 64. If I did positive 4, I'm sorry, not negative 4 squared, negative 4 cubed, excuse me, would give me a negative 64. So that would be 4 cubed. But if I did a negative 8 squared, is what I meant to say, that'll give me positive 64. If I did positive 8 squared, that'll give me positive 64. See where I'm going with this? So negative 64 may qualify as a cube, a perfect cube value, but negative 64 is not a perfect square value, though. Okay? Be mindful of the signs. For this second row of numbers here, just give it some practice. Whether if you're coming off the top of your head or using a calculator, that's fine. Hopefully you can kind of identify most of these, so just doing mental math. Take some time to categorize those as well. And then also take some time to notice and wonder about what those numbers have in common. Here, take a pause and write this down as well. A perfect square can be positive or zero, but a perfect square value will never be negative, ever, ever, ever. Now, a perfect cube can be positive, negative, or zero, but perfect squares will only be positive numbers. The reason being is because you cannot take a mix of a positive and a negative number. I can't do -5 times +5 to get -25. It has to be the exact same number that I'm multiplying to itself to square. Okay? Moving on. Though perfect squares have their own list of qualifications and perfect cubes, take note of the fact that we can square or cube just about any number. It really doesn't matter. Now, identifying perfect squares or perfect cubes is a different conversation, but you can raise any number to a square or cubed value. Okay? I demonstrated that here. I did number 6 and number 9 for you. I told you to do number 7 and 8 on your own. I hope you did. If you did not take time now to do that, I'm just going to rewrite what I did in class. We have 5/8 raised to a square power. If you can remember from our exponent chart on page 81 in your books, all I have to do is apply that square value to both the numerator and the denominator. That gives me 5 squared over 8 squared. If I evaluate that totally or just solve, that gives me 25 over 64. Done. That's all we had to do. For number 9, I did give you a warning, because naturally, I would want you guys to kind of re-identify this decimal number that it has, because it gives us 0.2, and just take the 2 itself and cube that value. 2 times 2 times 2 is 8, and just know that somewhere in your answer there's going to be an 8, but the answer is not 0.8 ever. The reason being is because we have one decimal place here, and if I'm going to raise this number to a cube value or a squared value, then I'm going to have to add another decimal place every time I multiply it. So since I'm multiplying it 3 times in total, I also need to have 3 decimal spaces, not 1. So our answer to 0.2 cubed will be 0.008, and we have 3 decimal places. Okay? Do the same thing for number 7 and number 8 in your spare time. If you want to, you can take a pause right here and do that now. Here I addressed that 81 over 100. Okay? Though it is not a perfect square, we can still break this number down and square root it to make the fraction even smaller. Don't worry about what's sitting below this. Just pay attention to this right here. Okay? We did 81 over 100 breakdown, and we square rooted it. Anytime you have a fraction, you'll have to square root or cube root those numbers individually, but then make sure you keep them as a fraction. Okay? You cannot square root the whole fraction. It doesn't make sense in your own mind. So take the square root of 81, which is 9, and then take the square root of 100, which is 10. That gives you 9 over 10. That is your square root value. That is how you break down those larger fractions. Okay? Also, because this is a square root value, anything squared, if it has a positive answer, usually it's going to have a negative answer too. So there's also -9 over 10, and that's what this is here. Okay? Capiche? Moving on. The same thing applies to this 0.027 here as well. I'm not going to do a physical breakdown for you. I'm just going to plug it in right quick, just for the sake of showing you that if I did a cube root This will give me 0.3. Why? Because I know that 27, if I cubed it, would give me 3 times 3 times 3, which is 3 cubed. But then we have to keep it in decimal form because that's the form that it's already in, and we have to stay consistent to that format. So instead of using 3 cubed, it is 0.3 cubed, or 0.3 if it asks you for an x value. Okay? If you ever need to double check, plug it in the calculator. A calculator will never fail you. It'll only fail you if you just don't know what you're doing. Same thing. Plugged in the cube root, we got 0.3. That's it. Here, I did a little bit of practice again for you. I did number 10 and number 13. I left you guys to do number 11 and number 12. We might check those when we come back to class, maybe. For number 10, it says, what are all the numbers that square? Write your formula, x squared, to 49 over 100. All that means is we're going to square root. I know off the top of my head that 7 times 7 is 49. So the square root of 49 is 7. The square root of 100 is 10 because 10 times 10 is 100. That gives us 7 over 10. Done. That's all we're doing. For 13, it says, what are all the numbers that cube? Rewrite your formula every time you see it to negative 0.125. Anytime you're given a negative value that's been cubed or is a cube value, a perfect cube value, know that your answer is going to be negative every time. Every single time. The reason being is because a negative times a negative is a positive, yes, but if you multiply by one more negative, that is how you get that negative value. We already know from number 2, when we were working with 5 cubed, 125 units, that 125 cube rooted will give me 5, or 5 cubed, better yet. Okay? But because it's negative, our answer is going to be negative. It's also a decimal, and it has 3 decimal places, so don't forget to keep it in proper form, and that gives us negative 0.5. Okay, so all this is just a breakdown of numbers. Do not be intimidated by it. Here was your exit ticket. If you have not completed your exit ticket yet, make sure you complete it and get it in. For 1 through 3, it says to state whether if the number is a perfect cube, a perfect square, both, or neither, and explain why. So just give a quick little sentence. It doesn't have to be a long paragraph, just a small sentence as to why something is or is not a perfect cube or square. For number 4, make sure you underline the word square in part A and write your formula. Make sure you underline the word cube in part B and write your formula, and then break that fraction down. Okay?